All right, so today we're going to take a closer look at the graphs of the sine and cosine functions and also look at transformations, start to look at transformations of sine and cosine, in particular, vertical translations. Okay, so just the vertical transformations, formations. Okay. So we're going to be looking at both vertical and horizontal transformations, but in this particular section, we're going to focus on the vertical transformations. So that includes the horizontal translation, or sorry, vertical translation, right? So translating or shifting a function up or down, and the vertical stretch and compression of a function. Okay, so, but before we get started, we need to talk about some of the key features of the sine and cosine function. Okay, so one thing you need to be able to do is just be able to sketch a sine function or a cosine function, just a basic sine or cosine function. So I sort of have a step-by-step process that I use for any sine or cosine function when I need to graph it. And so I'm going to start with an axis, and I'm just gonna graph the sine function. Okay, just sketch it. All right. So the first thing I want to do is I'm going to draw a little unit circle as well. So if you recall, the sine of a given angle is equal to its y value on the unit circle. Okay, so I'm going to start, we'll call this 0. And so, we're starting at 0, right? So the y value of this point, right, that's the point 1 comma 0. So the y value, which is the sine value, is 0. Okay, now if I go all the way around, that's 2 pi radians. Okay, and that's the end of one cycle, and then it just keeps keeps cycling over and over again from there. So what I want to do is I'm going to plot where one cycle ends at 2 pi, right? One cycle will end at 2 pi, and then it'll just repeat from there. So I'm just going to plot one cycle of the sine function. And then from there, I know there are 4 easy points to plot, all right? 0, pi over 2, which is 90 degrees, pi, which is 180 degrees, and 3 pi over 2, which is 270 degrees. Those are easy because I can see that, again, that's the y coordinate that I want to plot. Here the y coordinate is 1, right? So this is the point 0 comma 1, right? This was the point 1 comma 0. Okay, so at pi over 2, we're at 1. This point over here is minus 1 comma 0, so the sine is back down to 0. This point down here is 0 comma negative 1. Okay, so now the sine is negative 1, and then it goes back to 0. Okay, so that's one cycle of the sine function. So what I like to do is just break this section of the x-axis, or I guess this would be the theta axis, because we're plotting the sine of theta. Okay, and I just want to break it into 4 parts. So I'm going to break it in half, and then break it in half again. Okay, because I'm gonna plot pi in the middle. This is going to be pi over 2, and this is going to be 3 pi over 2, corresponding to these points on the unit circle. So I know it starts and ends at 0, and when we're at pi, again, the sine value is 0. Okay, and then at pi over 2, we're at 1, right? The y value on the unit circle is 1, and let's call this minus 1. At 3 pi over 2, we're at minus 1. Okay, so that's basically my process. As I plot the beginning and end of one cycle, and then break the cycle into 4 parts, and then plot the values at each of those 4 points, and then I'll just sketch this, fill in the graph, right, with what the sine function looks like. So, oops. There we go. So that's one, that's my sketch. Okay, that's all the more detail I need for a sketch. So let me, whoops, I didn't mean to do that. I was going to write down my steps here for you. So I always start by labeling the start and end of one period on the horizontal axis. And then I divide that period into 4 equal parts, all right? Then I plot the value of the function at each quarter period, okay? And then finally, I just fill in the sketch, right? Fill in the rest, just sketch the rest of the curve, just knowing what the shape generally looks like. So I sketch the function, okay? That's basically it. Now it sounds pretty trivial for if I'm just plotting sine or just plotting cosine. There's not, you kind of know what a sine wave looks like. But I use the same process if I'm plotting any other variation of a sine function, whether it's shifted vertically or horizontally, or if it's stretched or compressed in any way. I still go through the same process. Okay, so let's apply this to the cosine function. Now, let's see. I kind of want to have my unit circle out there too. So I guess I can redraw my unit circle. So I'll just scroll down here. So again, I'm just going to draw my axis. And if I'm just plotting plain old cosine, I'm just going to plot one cycle of cosine, right? And again, I can just use my unit circle. Only now I'm going to be plotting the x-coordinate on my unit circle. Okay, so if you remember, this is the plot. This is point 1, 0. This is the point up here at 0, 1. This one is -1, 0, and this is 0, -1. Okay, now we're interested in the x-coordinate. All right, so I'm going to start at 0. Oops, but it's not, I guess I should not plot that point though, because I'm starting up at 1, right? Because I'm plotting the x-coordinate, okay? And then one full cycle, let's mark where 2 pi is, right? I'm just gonna plot one full cycle. So, and again, I end up at 1, right? Because I'm ending back up at the same point that I started at. All right, and then I'm just going to break this into 4 equal parts. So break it in half again, and then I'm just going to start. So this is pi over 2. What's the x-coordinate at pi over 2? Okay, and the x-coordinate at pi over 2 is 0. Okay, what's the x-coordinate at? So this is pi, and this is 3 pi over 2. X-coordinate at pi is a -1. So let's see, this is 1. So let's say -1 is down here. So I'll plot that point here at 3 pi over 2. The x-coordinate is 0 again. So now you can kind of see how it's going. Cosine starts at 1, and again it has that nice curve, a nice sinusoidal curve. All of these are called sinusoidal functions, even though this one happens to be cosine. We still call it a sinusoidal function. Okay. So there's cosine. There's cosine. Just your basic cosine function. Okay, essentially it's y equals cosine of theta. Okay, this one was y equals sine of theta. Okay. All right. So what are the key features of sine and cosine? All right, the period of sine and cosine, just plain old sine and cosine, is always 2 pi. Right? They make one complete cycle in 2 pi radians. Okay, so the period is in radians. Okay, you could call it 360 degrees if you were plotting your angle in degrees, but for the most part in calculus we tend to use radians because radians make things nice. All right, just like the natural log makes things nicer for calculus, sine and cosine in radians is much nicer than in degrees. All right. Also, midline. So you notice that they were both symmetric about the x-axis, right? So the midline is just y equals 0 for both of those. Okay. Amplitude. Okay, so you notice that both of those functions go between, they go from 1 to -1, right? When the midline is 0. So the amplitude is just 1. Okay, that's the distance from the midline to the peak. All right, domain. Now we can keep going, right? I've only plotted one cycle of both of these functions, but I should make it clear though that this continues. If we keep increasing our angle, this function goes on and on in both directions. All right, just don't have it plotted, but it's just going to keep going. Same way with cosine, right? It's going to just keep going. So I could keep plotting different angles in both the positive and the negative direction. You know, I could just keep going. So we can evaluate sine and cosine for any real value of theta, right? So it was just, the domain is just going to be all real numbers in both cases for both sine and cosine. All real numbers. Okay, so domain is our input, so we can put anything we want in for a theta, right? The range of the function, you can see though, is fairly limited, right? We're never going to go beyond 1 and -1. So the range of both the sine and the cosine function is between -1 and 1. Okay, -1 and 1. Or if you want to write it in interval notation, it would look like, well, it would be square brackets, wouldn't it? Because we include 1 and -1, so it would be -1 comma 1 in square brackets. So that would be an alternate way of writing it. -1 comma 1 with square brackets, because -1 and 1 are both included. All right, so the symmetry. Now you can see right away cosine is symmetric about the y-axis. It looks, you know, the image of cosine is mirror image on the negative side, right? So essentially on the negative side is just a mirror image of what's on the positive side. So when that happens, okay, so the test for symmetry is to test the cosine of negative theta, right? And that's equal to cosine of theta, okay? So it's a mirror image across the y-axis, and so this is also called even symmetry, okay? So we have that symmetry across the y-axis. Now, the sine of negative theta, all right, when we put in negative theta, we actually get the negative sine of theta, okay? So this is called odd symmetry, okay? So, so you can see, like, if I have the cosine of pi over 2, if I put in negative pi over 2, I end up with -1, okay? All right, so those are all the key features of sine and cosine, and I will meet you in the next video.